So I just wanted to tell you guys about atmospheric science research powered by Python and Studio. So I use Python and Studio in my atmospheric science research to measure trace gases in the atmosphere. And we also use Python and R to analyze our meteorological data. So with atmospheric science research, we use different files in addition to the usual files, your .csv and your Excel files. So some of the files that we use are NITheCS that you will recognize with a .nc at the end of the file name, GRIB files, or HDF5 files. So I know everybody's probably wondering, what are these files? So NITheCS file, NITheCS actually stands for Network Common Data Form. This is a file format that is popular for storing the multi-dimensional atmospheric scientific data. So with the atmospheric data that we get, we have obviously the geography of where you are getting your data. You have your lat and lon, and then you also have the concentrations of the trace gases that you're measuring. And sometimes you have extra data such as the temperature, or you have the profiles of the atmosphere of where actually your concentrations are being measured. So we use NITheCS files because it helps you to store these data in their different dimensions, right? So then we also have a GRIB file, which is a gridded binary file. Now, this type of file is a concise data format, which is usually used to store meteorological data, such as weather, your precipitation, your solar radiation, and climate data. And these files are used mostly because, as I said, they're concise, so they're efficient for storing large data sets, right? And then we have your HDF files. These are your hierarchical data format. So these type of data files are versatile because they, instead of only just storing large data files, they also are able to store complex data sets, right? And they also are able to store a wide range of data types, such as radar data, climate model output, and satellite images. So when it comes to what we do with Python or R for our data, so after we get our different files, we will then clean our data, we will manipulate our data, wrangle them, and then we move on to our data analyses. So the different types of packages that we use in Python and RStudio for data analyses, some of them we went through them during the last week. We have NumPy, Pandas, Matplotlib. For RStudio, we have ReadR, NetCDF4, dplyr, tidyverse, ggplot, leaflet, and OpenAir. So for modeling, we did some modeling beginning of this week. For modeling, we will use scikit-learn and TensorFlow in Python. And then in R or RStudio, we use Caret and Random Forest. So for GIS analyses, somebody would ask, why use Python, why use R, why not just use ArcGIS or QGIS? But you can choose whatever works best for you. You can even, after cleaning your data, doing some statistical analyses in R or Python, you can then visualize it in your ArcGIS or ArcMap. So in Python and in Python for GIS analyses, we use packages called GeoPandas and Shapely. And in R or RStudio, we use TMap, RGDAL, Raster, RGeos, or dplyr. So please remember that this list is in no way conclusive. It's not all of them. There are other ones. These are just the ones that I am familiar with. And then for your time series data, in a situation where you have, like in this image, you have 20-year data, and you just want to see how the temperature varies per year. You can use, in Python, stats models and profit series data packages, or you can use Zoo, XTS, or ggplot2. So some of the data that we use, we have to get from the web, not necessarily from a certain instrument that we use. So you can also do what we call web scraping. So in Python, for web scraping, we use Beautiful Soup and Scrappy. And in R or RStudio, we use RVest. So I know that my presentation is very high level. And if you want to learn more about what we do as atmospheric scientists, or just to learn more about Python or R, you are more than welcome to join a data carpentry workshop. These workshops we run in the NITheCS community. So if you put your name down in the mailing list, you will get an email when there is a workshop that is coming up. You can sign up there, or you can go check out the Carpentry's website if there are any workshops that you would like to attend. Thank you.
Thank you so much, Refilwe, and thank you for advertising the upcoming workshop. Thank you so much. So questions, just a couple of questions for Refilwe. There is actually one from Benjamin. Can you give us the pros and cons between Python and R in the context of your research?
In the context of my research, so with R, for me, it's just the figures. R doesn't give me nice figures. And then because, I use Python and R together. I use Python and R. Sometimes I clean my data in Python and then move it to R. So for me, the pros and cons of using Python is that with Python, you have different ways. You can use the terminal, you can use Jupyter Notebook or Jupyter Lab. And on top of that, I get figures that are nicer than the ones in R, particularly. And then with the pros of R, for me, they all have the same, what's this, power, computing power. But I do hear people who are learning the other one before the other one saying that Python is easier. For me, they're all the same. So I really don't have actual pros and cons, besides the fact that I think the Python figures are nicer than the R ones.
Okay, thank you, Refilwe. So because of time, can you answer the other questions on Slack? And thank you again to you and Donovan.